Good evening, everyone. My name is Sandeep Yadav, and today I'm taking a fifth week tutorial session for the course Energy Economics, Energy Resource Economics and Environment. So my name is Sandeep Yadav. I'm a Prime Minister's Research Fellow at IIT Bombay in the Department of Energy Science and Engineering. Sorry, just I'll be taking a weekly sessions for the problems solving in this course. So this is the fifth week that I'm taking. So before starting, I just wanted to know if anyone of you having any problem in the solving the quiz and any other thing, so that I can still clear it. Or I will start with the session for the week 5. You can type in the chat box also. I can see that. And if you are uncomfortable in the, otherwise you can unmute yourself and type. Okay. I hope everything is clear. So let's before starting the content for the week 5, I will just briefly discuss the quiz of the week 4 that is already out. I think the answer sheets of the quiz is out, so I will share that whatever the yeah. So this is the quiz 5. So I will briefly discuss the problems and we will quickly finish it. Then we will start with the week 5. So I think week 4 is already deadline is already passed. I think so. Let's start it. So let's start with the question number 1. Question number 1 says, with respect to the probability of occurrence of resources, proven resources have the highest probability of the occurrence, followed by the identical and the inferred. So as explained in the slides by the sir also, proven reserves are the reserves that are proven, evaluated, what is the quantity that is available with them and how to mine them, because resources are generally need to be mined. So these are the most probable and most accurate stocks that are available. So the probability of these stocks will be the highest. So the correct this statement is true. If you want more explanation, here it is. Proven resources have the highest level of confidence and are economically and technically viable for the extraction, while the indicated and inferred resources are slightly less certain than proven resources. They are estimated based on the limited geological evidences and sampling, and the further exploration is needed to confirm their existence and the economic feasibility. I hope nobody's having any problem with this question. I will move ahead to the question number 2. So question number 2 says, let me see the chat box if you are having writing down anything. Yeah. Question number 2 says, an oil field has an proven reserves of 500 million barrels. If the current production rate is 10 million barrel per year, calculate the static reserve to the production, that is counting at a R by P ratio. So as we have solved in the previous uh, lectures also, R by P ratios calculating is very simple. We know R by P ratio stands for the proven reserves upon current production rate. So both the things are given. Proven reserves are given 500 million barrels, and the current production rate is given 10 million barrels per year. So that thing will give a 500 by 10 will give us a 50 years. So units will be cancelled out, as you can see, 500 million barrels, and the million barrels will be cancelled out as 500 barrels will cancel out, and the final things will remain in the unit of years. So the correct answer will be the answer number 1, that is 50 years. Anyone having any problem? Otherwise, I'll move to the question number 3. Okay, let's move on to the question number 3. What does the area under the curve of production versus time graph for finite reserves signify? Option number 8, total exploration activities. B, cumulative production of total output over time. C, reservoir capacity. Or D, current production rate. So it shows the cumulative production of the total output over the years. If you want explanation, or these things are available in the slides also. If you want more detailed explanation, you can just go to the energy economics part 2 and the lecture number 7b. So this says the area under the curve in the production versus time graph for the finite reserve signifies the cumulative production over or the total output of the resource in the given period. So this says the option number 2 is the right option. It also says it provides an insight into the overall utilization, depletion rate, and reservoir performance. What is the time available for the depletion, and what is the economic consideration or to the for the finite reserves. This metric is very crucial for understanding the dynamics and sustainability of the resource extraction operations. So the correct option will be the option number 2. Now move to the question number 4 that says that's asking which of the following can be estimated using the Pearl curve. Pearl curve is the curve that is as a S-shaped logistic curve. Option 1 is the maximum production. Option 2 is the production at the given time t. Option C says the infinite production. Option D says the time at which peak production will occur. So the correct the Pearl curve is used to estimate the production at the given time t and at time at which peak production will occur. So these are the two options. So this is a multiple choice question. Here we have to take the option number B and option number D. So as we can see, the equation of the Pearl curve is given by QP is equal to Q infinite divided by 1 plus a to the power E minus B Q infinity by T, where the QP stands for the production time. So the option number B, the Pearl curves, the option number B will be ticked out here, and QT is the maximum production rate that can be reached. So if we equate this with the if we differentiate it, then it will be d2 qp by dt square will be 0. Then we can find that time which is the peak production will occur, and the qp is giving the production rate. So if you will see, then correct of the time at which the peak will occur, it's giving us the Pearl curve by the Pearl curve and the production rate. So the correct option will be the B and D. Anyone having any problem? You can unmute yourself and talk. Otherwise, you can type in the chat box also. Okay, let's move to the question number 5. Question number 5 says, in estimating the time at which peak production will occur using static R by P ratio, exponential growth method and Pearl curve method, which of the following estimates the longest time period? So here it's asking about the comparison, which means what is the longest time period will be given by the which method. It's giving by the R by P ratio, exponential growth method, or the Pearl method. So the right answer for will be the static R by P ratio, because it does not consider the like it's considering the initial rate will predict the it will predict the longest time period, because it does not consider any of the modification occurs throughout the years. So suppose we are taking in that example, if we are taking the example 10 barrel per year in the year 2002, but here we are living in the year 2024. In this past 24 years, we have increased our production rate. But if in the static RBP ratio, it will consider only the 10 barrel 10 million barrel per year. But in the exponential and in the Pearl curve, that production rate will be vary. It will increase upon the time. So that means the time static RBP will be giving us a longer period. And if you are increasing the current production rate, but suppose in the year 24, current production rate will be like 15 to 20 million barrels per year. So the time frame will be the least. So that's why R by P ratio will give us the longest time frame. So let's move to the question number 6. If the static R by P ratio for the coal reservoirs is 350 years and it is depleting at the rate of 6%, then after how many years will the resource will be completely depleted as per the exponential decay model? So that's a numerical type of question. Let's see. So here we know the exponential decay model. It says n plus 1 is equal to ln 1 plus g r by p ratio, and ln divided by ln 1 plus g. Here n is the number of years in which the resource will be depleted. R will be the reserve, that is 350 years. 6 will be the depletion rate. So that's the production rate we can say. So in that way, it's taking the 6%. So 6 R by P ratio is 6. So here R by P ratio is directly given. So we can multiply this by the 6%. So it will give us the this ratio, and then we can calculate solve this equation, and finally this will give us the value of n is equal to 52, around 52 years. I hope this is clear to all of you. If you have any problem, you can just unmute yourself and talk. Otherwise, you can talk or write your query in the comment box. Now let's move to the question number 7. It says, what is the primary source of heat that drives the geothermal energy? So it's a very basic question. What is the primary source of heat that drives the geothermal energy? First option is the solar radiation. No, this is not a primary. Second is the nuclear reactions. No. Third is the earth internal heat. Yes, earth's having its own internal heat that is giving the primary source for the geothermal energy. That's why it is called geothermal energy. And the combustion of fossil fuels. No, that's absolutely not. Explanation is of this is geothermal energy is the primarily derived from the earth's internal heat. This just a minute. Yeah. So geothermal energy is the primarily derived from the Earth's internal heat. This heat originates from radioactive decay of minerals within the Earth's crust, and the heat retained from the Earth's planet's formation. In geothermal energy systems, this natural heat reservoir is harnessed to produce electricity or provide direct heating. Unlike solar or wind energy, the geothermal power is not dependent on the external factors, and we can harness consistently, making it reliable and a sustainable source of renewable energy. But why it is not used? Due to the economical perspective and the type of heat it is releasing. I hope this is clear. Let's move to the question number 8. Question number 8 says, if if one goes from 50 meter above the ground to 100 meter above the ground, the wind speed will typically reduce by half, reduce but uh, less than by half. It will double or increase, but less than double. This question I've already solved in the previous problem solving session in the last Tuesday. It says we already know there's a ratio that's V2 by V1 say divided by the V2 by V1 is equal to Z2 by Z1 to the power alpha. Here Z2 is given. That means Z is the height above the ground. Z2 is the 100 meter, Z1 is the 50 meter, and since alpha is ranging from the 0 to 0.1 to 0.4, we can calculate V2 by V1. So change in the V2 by V1 will be typically from 1 to between 2. So that will be correct option will be D, increase but less than it doubles. So if you do solve this equation, it will typically come out to 1.7, I think. So that will give you the exact answer. Now move to the question number 9. Which instrument is specifically designed to measure the direct normal beam radiation from the sun? Pyranometer, pyrheliometer, photometer, or the radiometer? So that's a direct question from the slides itself. It's the pyrheliometer. Pyranometer is an instrument specifically designed to measure direct normal beam radiation from the sun. It typically consists of a thermopile sensor and that absorbs the sunlight from and produces the electrical voltage proportional to the solar radiation intensity. Pyranometers are widely used in solar energy research, meteorology, and climate studies to quantify the direct radiance received at the Earth's surface. Direct means that is directly impacting to the earth. Suppose there's a sunlight impacting on the building and then impacting to the earth surface. That is not a direct light. Directly means that is directly impacting to the solar panel. So that pyranometer is measures a wave, single light source used to measure the direct normal beam radiation. Question number 10. Which of the following statements about the tidal energy is correct? Tidal energy is direct form of solar energy. Tidal energy is primarily driven from the wind patterns. Tidal energy is generated by harnessing the gravitational forces between the Earth, Moon, and the Sun. And the tidal energy has a negligible impact on the marine ecosystem.
Option C.
This is already written here. Uh, So tidal energy is generated by harnessing the gravitational force between the Earth, Moon, and the Sun surface. So it says tidal energy is harnessed by capturing the gravitational interaction between Earth, Moon, and the Sun. The gravitational force creates tidal movement and Earth's ocean, resulting in a periodic change of the sea levels and the tides. Tidal energy technologies aim to convert these natural ebb and flows tides into the electricity. Unlike the wind solar, tidal is predictable and consistent, making it promising form of renewable energy. I hope this is shows solves your all of the problems in the quiz 4. If anyone is facing any problem in the quiz 4, you can just I will just wait for 2 minutes. Till then, you can ask your queries. Otherwise, we'll move to this week's session.
So can you repeat question number 3? Like
Question number 3. Just wait. Question number 3. What
yes.
does the area under the curve of production
Yeah,
rate for
yeah,
the
yeah.
versus time graph?
Yeah, yeah. So that's
So production rate, I need to show the slides. Production rate versus time graph for the finite reserves shows the cumulative production of the total production over the time. Suppose there's a graph. Just let me show it to you. Yeah, if you will see this slide, I'm not getting the exact slide, but if I can explain to you from this slide, I hope you can see. So
yes, sir.
question says which of the following is estimate? Sorry, question number 3 says what does the area under the curve production versus the time graph? Production versus the time graph. The production. This is the production rate that is given by QP. So suppose production rate is 10 million barrels per year. So in the 1920, it's only 10. If you consider this is a 10, in the 1930, it will be 100. Oh, sorry, if it is one, then 19 in the year 2000 around this 1980, it will be around 100. So if you can see, this is the so area under this curve, like production rate versus time. This curve will give you the cumulative production. In the year 1920, it will be 1. In the year 1930, it will be 10. In the year 1917 or 1980, it will be 100. So it is giving us the cumulative production, like how much oil we have generated throughout the years.
Okay.
Okay, got it.
Yes, sir.
If you want more explanation, this will be already given in this slides also. You can just visit the lecture number 7B, and that time snap is also given, like 4 minutes 25 seconds.
Okay,
You will
okay.
get the exact explanation of this.
Okay.
Okay.
Thank you.
Anyone else facing any problem? Or we'll move to the slides of the question number week 5. Close this. I hope everything is clear. So let's move to the content for the week 5. before directly jumping to the numerical or the short type or multiple choice questions, I will just briefly explain you the content of the lecture file. That is detailedly explained by the sir, but I'm just giving you a brief so that it will be easy for you to solve the tutorial and the problem solving sessions. Let's start. So the this is the continuation of the lecture 8A and in the past lecture that is discussing the energy like materials. What are the materials that we are using in the to recover or use the energy? So this having the few questions like will we run out run out of the materials? Can we create a closed loop material system that will be sufficient to mine the energy that is available to the earth, or which renewable energy material will be constrained and what will be the impact? Suppose you're using solar panels. So does we have a sufficient amount of silicon available that will last throughout the earth's lifetime, or we have to find some other resources than the silicon, because silicon is the major material that is going to be used in the uses of this earth. Oh, sorry, solar energy. So this there are very critical materials that is going to be used by the major population like steel, cement, plastic, aluminum, paper, or various other. The major of them is going to be used by the is it's generally used by the industrial, transport, buildings, and the other. So this will be giving us the net or the global carbon emissions of 28 gigatons of CO2. That's data is very old, like 2011. That's now way ahead increased. So this is the periodic table in which all the materials are classified, like which are the green ones show the materials that can be used in the photovoltaic, orange one shows that materials can be used for the hydrogen storage, blue underlines shows the materials that can be used by the fuel cell, and black one shows the materials that are shown can be used for the batteries like lithium, nickel, cadmium, and the lead. This is the material efficiency. Suppose that some materials that are going to be used initially, like when the solar panel or the batteries are increased, initially we are using the as a liquid batteries. Currently we have moved to the more efficient material, that is lithium ion or the sodium ion batteries. In the future times, in the near future, we will move to some other materials that will be more efficient than the lithium ion batteries. So this is called a material efficiency. And this is some material strategies like energy efficiency. Energy and the carbon efficiency can be increased by the energy efficiency, recycling, and the carbon capture processes. And the material efficiency can be increased by the longer life, more use, or we can repair the same material or the same equipment, can reuse, resale, or product upgrade, component of reuse, less better same service. Suppose if you will, I'll take an example of a aeroplane. Initially, the aeroplane or some let's take an example of a car. So if you see an old car that will having a more material, it will be more bulky, but due to the less like material efficiency, we have just minimized that material to the most optimum one, and currently we are getting more lightweight materials that will be giving us the same strength. This is the global material usage that is continuously increasing between the different like cement, steel, iron, paper, and ammonia. I will not. So initially, what happens when the any of the new material comes in, it will follows like a bell-shaped curve. So if you will see, when the if you compare between the India and the US or Europe, India is currently using very less per capita of steel as per used by the uh, North America. because in the initial development phase, India is using more and more steel, but and the America has been saturated. As we can see here, it had attained the peak, and now it's in the decreasing fall because they have all developed all the bridges or all the infrastructure that is needed for their population. But India is currently on the increasing phase. This is same applies for the cement and other materials. This is a very beautiful graph, shows the material choice. Suppose we want to make anything. This is a basic graph that shows the embodied energy per cubic meter versus the Young's modulus. So suppose you have to make a railway block, and what you need in the railway block, you need the highest Young's modulus of elasticity and the highest embodied energy. So the correct option will be the metals. And if you want to use the lighter material with the most like lighter material with the highest amount of embodied energy, you can use the silicon or the polymers that can be used in the or the ceramics that lies in this range, like in the composites, which are lighter and having the around the similar Young's modulus of electricity, the Young's modulus of elasticity. Sorry. Now moving ahead, this is the embodied energy of different materials. Sorry, just misbehaving. Yeah, embodied energy of different materials like aluminum, copper, iron, and magnesium is given. So this is the terminology by betting the professor Julian Simons that said that resources are not infinite, not finite. So it says that whatever be the we will use going to use that resources that will be reoccurrent, that will last as long as we want. But that theory is countered by the professor Malthusians that say that resources are very limited. We have to use them very efficiently. So there's a batting story that has already told you. I'm not going to reiterate. Uh, let's move to the. This is the about the same story. Now we move to non-renewable energy economics. So this says this is majorly there where we are going to use a story or like methodology of hoteling. So Hotling says the Harold Hotling, the economics of exhaustible resources, published in the 1931, that showed has given us some examples the theories in which pi t is the profit in the period t is equal to the pt qt minus c qt. Pt is the market price of the resources, qt is the output of the resource in the period t, c is the marginal cost of revenue. So this is the pi t will be equal to this terminology. Sir has already explained this whole phenomenon, all the derivations has been done. So I'm not going to derive the derivation for you. So you can just visit the videos for the more details. We will solve the basic numericals on that, so that will give you the more clarity about the concept. So the same formulation. This shows the as per the price of that is increase when the time and the when the price is increased, its demand is getting is decreases with the time. Totaling rule, that's it. It's a linear inverse demand curve, and this is the price elasticity model that we're going to use in the some of the numericals. This curve shows the linear model price trend, and this is the same. Let's move to the. So there are two types of market. That is, one is the competitive, other is the monopoly. So we have seen the derivation for both the competitive as well as the uh, monopoly market. We have calculated the price, like how much time it will take to exhaust a certain amount of oil or certain amount of coal for that period. This is for the monopoly market. So the time that we can calculate our, we can put the values of resource and the discounted and the time period, and we can see calculate the at what amount of time our resources will exhaust. Is a beautiful graph which when the competitive and the monopoly markets. It says in the competitive market, this graph shows the competitive market. Let me just point it out. Yeah, this one, the most deeper one shows the competitive market, and the like less deeper graph, this shows the monopoly market. So it says in the monopoly market, resources will last longer as compared to the competitive market. As we can see here, the time horizon is longer than the competitive market. This is the problem that's all been solved. So if anyone of you having any problem, I can still resolve. Otherwise, we'll move to the tutorial or problem solving session of this week. I'll give you 2 minutes so that so let's move to the weekly live problem solving sessions. So in the this week we have covered a topic like material used in the renewable energy, Cousinets curve, betting on the planets by Professor Simon and Malthushian, and non-renewable energy economics that majorly contains the hoteling rule and shows the competitive market and the monopoly market. Uh, Moving to the question number one, achieving material efficiency by getting the same function using less material is an example of. So this is the choose one of the options which applies the closest. That means you can't apply, you can't take the more than one options. It's a single uh, choice question. So any one of you want to answer this question? Achieving a material efficiency by getting the same function using less material is an example of dematerialization, lightweighting, remanufacturing, or redesigning. Anyone? You can write in the chat box also. As much as long you will interact, it will be give you more insights about the problem solving session, and this will be the questions that will you will be facing in the quizzes as well as in the answer. So let me see, there's some option redesigning, option number A. So two people have commented the redesigning. Very good. So right answer is the redesigning. Both of you are correct. So it says dematerialization is the reduction of amount of materials and energy used in design solution. So that means lightweighting will also be done, but closest answer is the dematerialization. I hope this is clear. Both of you given the correct option. Question number two. What did the professor Julian Simon believes about the resource and their prices? We are facing a scarcity of resources, hence their price will increase. Option B says we are facing a scarcity of resource, hence their price will decrease. We are not facing a scarcity of the resources, hence their price will increase. And option D says we are not facing a scarcity of resources, hence their prices will decrease. So Arnab and Shivraka says the option D. Then we also to join the chat. So it's also D. Anyone else? So Professor Julian Simon. Here the in the 1980, they have come came up with a bet that says resources are not finite. That means whatever the theories that or the economics and the environmentalists has given, they are not finite. That means whatever the amount of resources available that going to be sufficient throughout the lifetime of the. Thus, he predicted he predicted that in the long term, the price of this resources will fall. So whatever the resource that we are going in 1980, the price of these resources will fall. So this is the theory that he has given. So generally, what happens when any of the resources starts depleting, its price will slightly increases. Suppose that oil we are using, like in the price of the petrol in the year 2003 or 4, we can in India we came around from the rupees 36 rupees per liter. Currently, it is more than 100. So it's giving the theory, but Professor Julian Thompson, it was wrong. It says the price in the upcoming time will be decreased. So he says we are not facing any scarcity of the resources and their prices will decrease. So this is the theory that he has given. The correct option will be question number D. So let me explain you with this some more explanation. So he has came up with a theory, but this theory at that time is he has also been uh, won that battle. So what he said, just see. Yeah, yeah, yeah. So he said that initially in the contrary of that, Professor Malthusian said that resources are very finite and that price will increase. So they have initially in the 1980 they have gone for a bet and they have seen and so there are five materials that they have chosen. One is the chrome, copper, nickel, tin and tungsten. Both have came up with the $200 in the 1980, and the time frame was chosen for the year 1990. That is a time frame of 10 years. So it's a graph. Suppose there's a graph shows between the different commodities that has been taken, like in the chrome by the shown by the like we have seen the tungsten. So here tungsten, if you can see this the graph of tungsten in the year 1980, tungsten was around 500. The price was 500. In the year 1990, it decreased around 100. The similar thing happened to the all the metals that has been considered, like copper, tin, nickel. But all the about this controversy, this theory is only correct for this time period, like from the year 1990 to 1980 to 1990 only. After that, this all the prices is going to be has been increased. So he's very lucky at that time. He's won the bet also, but this theory is not applicable universally. So in the if you can see the price of all the other commodities in the year 1980, the prices was slightly decreased to the year 1919, and then it's shoot up. As we can see, the year 2000, it shoot up to and it's still increasing. Same thing happened for the heavy metals. In the 1980, the prices were higher, and then in the 1990s decreased, and currently it is increasing. So there's a lot of variation, and this similar thing holds correct for the all the variations. So let's move back to the things that we are. Okay, so I hope this question is very clear to you. You have had a detailed explanation. Now let's move to the question number 3. It says consider the Kuznets curve of the regions marked as A and B and the plot given below. Which of the following is true? So this thing we have already just discussed. Here, this section number A, if I will highlight the section number A, and this is the section number B. It says which of the following is true? A is the developed region, A is the developing region, B is the developed region, or B is the developing region. So it is a multiple choice question. You have to mark two options at least because two options are correct. Anyone of you want to try this question? You can just comment or unmute yourself. B and C. Anyone else? B and C. Anik, Arnab. Let's see. Option number like A. A is the what region? It is the developing region. An example of developing countries like India. India is here in that graph. And here it is graph for the Europe. It is for the Europe, or this is for the majorly for the North America. As we know, Europe and North America are the developed region. So this graph shows the so let's delete North America. This doesn't consider. So this graph is the for the developed region. So B is the developed region and A is the developing region. The correct option will be B and C. So all of you three that commented is correct. Anyone needs any explanation? Otherwise, we'll move ahead. Let's move ahead. Same thing. This is the explanation that is already given by me. This is the same thing. Like the developing region, like country showing the trends where the developed nation like B showing the growing trend. So this graph initially when any country is developing, this like percentage cement consumption per kg with the increase in the per capita GDP. So when the country is developing, its GDP is increasing as well as the consumption of the cement is increasing. And when it is increased, it attains a peak and then starts decreasing. So currently, this you can see there's a decline. Here also you can see a decline. This is for the North America, and this is for the Europe. So initially it decreased. So currently India is here. So we are developing. When we will attain some like infrastructure developed for all our population, our GDP will be grow in a slower rate, and our per capita consumption of the energy resources and the materials will also decrease. Anyone having any doubt? Let's move to the question number 4. So question number 4 says, India recently announced discovery of the following materials in Jammu and Kashmir, which has the following plays a significant role in the energy transition. It's a very current affair question, you can say. Option 1 is says the cobalt. Option B says the lithium. Option C says the uranium. Option D says the mica. This is recently has been in the news. Which of this material has been? I'll just give you a hint that is related to the batteries. So when I say batteries, there are only two options here that has been used in the batteries. One is the cobalt, one is the lithium. But in the Jammu and Kashmir, recently found minerals by the lithium. So B is the correct option. So if you want more explanation, geological survey. Geological Survey of India. That is briefly called GCI. Has first established lithium inferred resources that they have categorized as a G3. So G3 around they have found 5.9 million tons. In which area they have found? In the area of Salal Haimana in the Resai district of Jammu and Kashmir. Lithium is primarily used for the batteries.
Yeah, lithium ion battery.
Correct. Anyone?
What does the
Making
G3 mean, sir?
G3 is the type of resources, like what kind of there's a type of resource that is mentioned in the Geological Survey of India. If you want more details about this, or what is the whole news that is already available on the website, I will just give you a link in this lecture slides. You can just go through that or the whole news. What is the G3 and what is
G3
the
is
amount of?
superior quality or inferior quality?
So that thing I have to go through with the
अच्छा,
news
ठीक
itself. Yeah. Okay. Now let's move into the question number 5. Scarcity of the material will always lead to increase in the price of resources. Is it true or false? Scarcity of the materials will be always lead to increase in the price of resources. Have you seen that graph that has been in that slide? Let's go through this. I think. Yes. So if you have seen this graph, if you remember this graph. Yeah. This graph. This graph says when the demand increases, the price will decrease. The prices is going to decrease when the demand is increases. So that means scarcity. Scarcity means when the material will be scarce, the price will increase. So it's a historical trend. Historical trend shows that there's a scope in the technological improvement and the price may actually decline. Suppose there's a one new material that is found. Initially, silicon were found for the solar panels. So when it is optimized, now we can get the silicon and the batteries and the lithium ion batteries on the lower prices. So it shows when the initially some technology is found or material is found, it is initially having a higher price, but with the technological improvements, its price is going to be decreased. So that statement is false. So we'll go back to the question. The question is, initially when the price is there, price versus so price will with the technological improvements. Let's move to the question number 6. So that's correct option of this will be false. Now, which of the following represents the constant elasticity demand function? So here you have
So
to
sir,
make a
please
note.
explain the previous one again.
The previous one says initially when scarcity of materials will always lead to the increase in the price of resources. So that does not hold true. When a material is scarce, suppose with the, as a material initially it will be in the higher prices, but when the technological improvement is increased, suppose initially if you will see the iron, price of iron was higher, but when we technologically improved the price of technology improved the iron with the stainless steel, so price of stainless steel has increased, but the price of iron is has been decreased because it's serving less user base, and stainless steel having the better properties. So these technological improvements will lead to the will not always increase or always decrease. So here the all the things will stand for the always. It will not always lead to increase the prices. It may decrease also.
Okay, got it.
That's what I say.
So, sir, so
Yes.
you mean to say that whenever we will try to improve the quality of certain metal, then in that
Mhm.
case, the price will increase. Keeping in mind
Yeah.
by keeping in mind the means the original quality of that material has decreased. So that's what you
Correct.
mean to say, right? Yeah.
Yes. So that does not always mean to suppose in the stainless steel there are also some version stainless steel K04 stainless steel K0316 that has been for the different applications. So that will not always holds true. So but this statement that is saying scarcity of material will always lead to increase in the price. That will not hold correct. It
Okay.
may be increase, it may be decrease, but not always.
Not always.
Okay, thanks.
Okay. Thanks.
Okay. Let's move to the question number 6. Which of the following represent a constant elasticity to demand? Note that A and B are the positive constant. So this has been solved in the class also. You can just see.
So
Anyone
the derivative
want to answer?
is a dq by
Yeah,
dt.
it's
Derivative
yeah.
part we have to calculate. We have to differentiate that each of the
Correct,
expression
correct, correct.
and then.
Yeah, you have to differentiate all these expressions.
Oh,
Most of you want to answer option number B. So B is the right option. Let's see how it is. So it says which of the following represent a constant elasticity demand function. So for the constant elasticity demand function, we have to see the magnitude of elasticities. That is dQt divided by Ut upon dPt upon Pt. So this thing we have to calculate for all the fours, all the four options. So when we calculate in the option number 1, d so when we calculate for the option number 1, this will you can just solve it for yourself. This will come out to be bqt. And for the option number B, when we calculate this thing, this will come out to be 1 by B. Option number C will come out to be A by Q by T. And option number D will be E A to A minus QT square divided by QT square into T. So here we can see and the option B is having, oh sorry, only option B is having the demand function with a constant in the elasticity. So that means that will represent the constant elasticity. So if you can see only B, that option number B is containing this. The correct option will be the option number B. I hope this is clear.
Yes, sir.
Let's move to the question number 7. A resource lasts longer in which type of market? Monopoly, perfect competition, none of the above, or last the same? I've just reiterated this thing in the many times. You should be able to answer this. Let's wait for the 1 or 2 minutes. If people answer. It's a very basic question. Yes, most of them commented option number A. So option number A is the right option. Can any one of you want to explain me why? Why in the monopoly market resource will last longer? You can just unmute yourself and why the monopoly market resource will last longer. Any one of you? Okay, let me explain. So what happens? There are two types of market. One is monopoly. Second is competitive. So in the competitive market, when a product demand increases, they will release that amount of material. Suppose when a demand comes for a product, suppose in a particular year you are using in the COVID time. In a COVID time, if you will consider in the COVID time, you are using a some amount of sanitizer mask. So if that market will be a competitive market, then whatever the amount of mask or sanitizers you are going to be need in that time frame, that market will supply to you. That means that will exhaust. Suppose there are 100 crores of sanitizer and masks are available. So when the demand will increase, when the demand will increase, or there is a certain amount of time demand will increase, then you have the limited amount of resources. You will when the demand increases, you will supply more material. You will supply more material. That means the resources will be consumed as at a faster rate. While if you compare to the in the monopoly market, what the monopolists do to maximize the profit, in a particular year, suppose in a particular in a particular sorry, in a particular year they will release only a certain amount of time. They will release only a fixed certain amount of resources. to increase the price. Suppose when the in the market the when the amount of as you have seen in the COVID times, the amount of oxygen at that time there is not sufficient supply of the for the oxygen, so that the oxygen cylinders are getting at the price of at the higher rates. So what monopolists did at their when the demand was not met, the price will increase, so that will maximize their profit. But on the other hand, the resources, suppose the resources available at the 100 crores of cylinders, so that resources will be depleted. The resources will deplete slower. So that means the resources will last longer. I hope every one of you got the explanation. If you have any doubt, you can just tell. Otherwise, we'll move. So that is why the in the monopoly market, resources longer as compared to the competitive market. Just give me a minute. Move to question number 8. It says, which is the most important application of the lithium? Yeah.
Sir, can you give an example of monopoly and competitive? Like, but I have understood
just,
that difference between. Just can you just experiment? Give a difference example.
Yeah. Okay. Suppose there's a scarcity of tomatoes. There's in a season of time. Not tomato. Let's take an example of onions. Onions can be stored for a longer time as compared to tomatoes. But if there's a demand of 100 tons of tomatoes per year for a city. So there are two types of market. One is competitive, one is the monopoly. In the competitive market, when this demand is increased to the 120 10 tons per month. So in the competitive market, they will increase the price and but supply the same amount of with the prices will be constant and the amount of that supply will be increased according to the demand. But in the monopoly market, when the demand is increased, they will not supply. When the demand is increased and the demand is increased, but as supply is lower, then what will happen? Everyone will need that onions to their home. Then that will increase the price of to maximize the profit. But that resources, suppose there's a only 100 tons of onions are available throughout the year. In the competitive market, that will be exhausted in the few months. Like if the initial consumption was 10 tons per month, then it will going to exhaust in the 10 months, but it is increased to 15. Now it's exhausting the only for the 5 to 6 months. So that's an example of this. Like in the, you can say resources last longer in the monopoly market because they will just release a certain amount of time to increase to maximize the profit.
Okay.
Okay.
Thank you.
Anyone else? Okay, let's move to the question number 9. Question number 8. Question number 8 says, which of the most important application of the lithium in the energy sector? This is a very basic question. All of you, I think, can answer. Anyone want to try? Option A says the batteries. Option B says for the photovoltaics. Option B says for the fuel cells. Option C says the hydrogen storage. So here the things is this lithium is also being used by the fuel cells and the hydrogen storage, but majorly it is used for the batteries only. That's why it's question asked. What is the most important application of the lithium ion in the energy sector? The most important stands for the batteries only. So the right option will be the, as all of you commented, option number A. Right option will be the option number A. I hope this is clear to everyone. I don't need any explanation for this. Let's move to the question number 9. It says match the number highlighted in the red in the given diagram with the corresponding energy material strategies. So as this graph I've just shown in the explanation part, you've seen it says match the number highlighted in the red. That means number 3 and 4. So this graph shows the production forming of production from the scrap. This was a graph between the energy, carbon efficiency and the material efficiency. So you have to see what is the number 3. Number 3 is recycling, carbon capture or recycling. So on number 4 will be product upgrade, carbon sequestration, repair, resale or energy efficiency. On option 5 will be repair, product upgrade or yield improvements. Any one of you want to try? I know it's a bit tricky one. Anyone of you? Well, let's see all of them one by one. So here we have seen there are two things. One is A, no, sorry, option number C. Okay. Here we have seen energy and carbon efficiency. In which, so there are two things. One is energy and carbon efficiency. Second one we have studied is the material efficiency. So in the energy and carbon efficiency, there are three things. What are three things? Option number one. Option number one said it's a energy efficiency. Option number D is also a part of energy efficiency, energy and carbon efficiency. This says as a carbon capture. Carbon capture. So option 3 is now fixed. Option 3, it's the highlighted part. So right now our answer will lie in the B and C. It says the carbon capture. Option number 3 is carbon capture. Option number 2 is also a part of energy efficiency, and it says the more recycling. And now let's come to the material efficiency. So material efficiency, there are 5 parts. One is fourth one. Fourth one is for the longer life. That says longer life. So now if you will see, longer life means repair and resale. So option number 4 will lies for the repair and resale. Here we have already got the answer. Like option number C will be the correct option for the getting more understanding. So this will solve all of these parts remaining. So longer life, repair and resale. Number 5 here. Number 5 is product upgrade and remanufacturing. Option number 5. Option number 6 is component reuse. It's a component reuse. And option number 7. That's number 7 is less metal and the same service. We have already solved the one question on same less material, same service. What it was called? It was called dematerialization. Same function of using the less material. We can call it a dematerializing. And option last, but last will be yields improvement. It will be, sorry, it will be yield improvement. So I hope this thing is clear. If you want more clear option, this is the thing. So here we have seen 1, 2, 3, 4, 5, 6, 7, 8. You can just recollect this graph from this explanation, and you can see what is the two things. So right option will be the option number C. Let's this. Yeah, I hope this is clear. Anyone having any doubt? Otherwise, we'll move to the question number 10. Anyone wants to try question number 10? It says price elasticity of demand reflects rate of increase of demand, change in the demand per unit change in price, percentage change in demand per unit percentage change in price, or percentage change in price per unit percentage change in demand. So I've received option number B, C, and C. Let's see. It says price elasticity of demand. So by the definition of price elasticity, it says it is the percentage change in demand per unit percentage change in price. Have you do you remember that slide? If you go to the price elasticity of demand, it says, yeah, here it is. It says yeah. By the definition itself, it says dqt by qt. It says price percentage change in the demand per unit change in the price of. This is the per unit change of the. This thing is the. You will see this thing is the per unit percentage change in price, and this thing is the percentage change in demand. I hope this is clear. So right answer will be option number C. Option number now moving to the question number 11. Anyone who's having any doubt? I think this is a very basic question. This is already been defined in the definition itself. So let's move to the question number 11. It says for a constant elasticity demand function, that is PT. PT is equal to A QT to the power minus B. What is the choke of terminal price? Anyone who, if you want to try? For a constant demand Number D does not exist. Number D does not exist. So let me explain. So what happens? Chop of fries. What is a chop of fries? Chop of fries is the price at which the quantity demanded falls to zero. However, for a constant elasticity demand function, the quantity demanded does not go to zero for any finite value. Thus, the choke of fries does not exist for the constant elasticity. For constant elasticity, I hope you remember this graph. Constant elasticity. Quantity demanded does not equal to zero. That's why it does not exist. If you want more explanation, I can just show you the graph. If you have seen in the constant in the inverse demand curve, you can see the quantity is can be equal to zero. See this thing. The quantities can be zero, but in the constant elasticity demand. Here also you can see the quantity can be zero, but in the constant elasticity demand, this will not equal to zero. Constant elasticity inverse demand curve, you will see it will attain zero at the infinite value. It will just becomes constant after some amount of time of production rate. So it will not achieve zero. That's why the chalk off price or terminal price, or what do we say, will not be equal to zero. Let's move to the next question. If any one of you are not having any query. So very good, you all of you are participating, and so that we are getting some more insights about this questions, and that sessions will be more. So this is the last question of the short type questions. It says in which case of a linear inverse demand curve, how will the extraction paths change with the discount rate? Just a minute. Yeah, anyone one of you want to try? In a case of linear inverse demand curve, how will the extraction path change with the discount rate? Option one says the resources will be exhaust faster if the discount rate is lowered. The resources will get exhausted faster if the discount rate is increased. The resources will get exhausted slower if the discount rate is increased, or none of the above. Correct. So right option this will be the resources will get exhausted faster if the discount. So it says the discount rate is a function of resources. If discount rate is a function of then the if discount rate will increase, the resources will uh, resources will exhaust faster. Correct. So right option will be option number D, as most of you commented. Good. So now we will move to the numerical type questions. This type of the questions you have also faced in the quizzes also, and similar type of question you are going to be faced in the exams. So that's important to note what this question is asking. Let's solve it. Question number one says, if the demand function is expressed as 3pt plus 6qt is equal to 600, determine the stock of price, that is the price at which the quantity demanded falls to 0. Also, calculate the initial price. Assume that the discount rate is 10% and the resources will last for the 15 years. Express your answer in the correct two decimal points. So in the numerical type questions, decimal points is important. You have to round off your values up to 2 or up to 3 values after the decimal to get the in the range, because the answers are always fixed. So here answers are falls in the range. Suppose there's a range of your answer is 11. So your range will be given to 10 to 12. You have to fall in this range. Okay. So let's solve it. So it says demand function can be written. This is the demand function. Demand function is 3pt plus 6 qt is equal to 60. If I will take 3 as a common from both of this will be 2 qt will be equal to 60, and pt plus 2 qt will be 60 divided by 3 will be 20. So our demand curve can be written as this way also before solving, or for realizing. If you want to write in the terms of pt will be equal to 20 minus 2 qt. So we can write our function in this way also. So according to the definition of choke price. Choke price is the price at which qt equal to 0. We already know. So if we will put qt is equal to 0 in this, then pt will be 20 minus 2 into 0. pt will be equal to 20. So we have solved for the as a first part of the question that says the price at which the quantity demanded falls to 0. That price will be pt. pt will be equal to 20. So we have solved the question number part number 1. Now it says calculate the initial price. So for the initial price, so for initial price, any one of you faced any difficulty in this till now? You can ask in between also, otherwise we will move ahead. So for the initial price, we have to see discount rate is given 10%, and so we can write 0.1. Time period, or that is return resources will last, is 15 years. So t is equal to 15. Okay. And one thing that we have calculated from the previous question is pt. pt was equal to 20. We have just calculated pt. So now we know pt is equal to p naught 1 plus d to the power t. So we know that value of p. So p naught is the initial price. So right now we know pt. We know pt. pt is equal to 20 is equal to p naught we know the discount rate 0.1, time period we know the 15. So if you will solve this equation, that will give you the value 20 is equal to P naught 1.1 to the power 15. So that will P naught will be 4.79. I hope everyone got this solution. Just wait a minute. I'll just give you 2 minutes to so that you can rethink this solution, or otherwise we'll move ahead to the next question.
So this is the initial price, right?
Okay, I don't see any comments, so I'll move
Sir,
ahead. Yeah,
so this is the initial price, right? P naught?
P naught is the initial price, correct?
Initial price, okay.
Okay, so let's move to the next question. It says for the same demand function, let's remove the same. For the demand function as above, 3pt equal to 5qt is equal to 120. Calculate qt at the time period of 5. Assume that discount rate is 10%. Resources last longer for the 10 years. For the same demand function as above, calculate the magnitude of price elasticity at t is equal to 0. Assume that a discount rate is 10% and the resource lasts for the 10 years. So this is the again 2 times is given. So this just consider as the same. Anyone want of you to try this question? This is the quite similar from the previous one, but not exactly the same. What thing we have to do first? First thing is to write the demand function. So we know the demand function is given as
Then we have to take
dp.
qt common.
Correct. Not qt.
Okay.
See. Here nothing that we can take common. So we can just write in the terms of pt. So whenever you get the demand function, you just write it to the demand function of qt. So qt will be 120. So 3pt will be 120 minus 5 qt, and pt will be equal to 120 minus 5 qt divided by 3. So this is the thing that we have written in the form of pt. Now, what says the next part? Calculate qt at the time period t is equal to 5. What it says. So when we put qt is equal to 0, what happens? We'll get a constant that we call a. When you solve the numericals, you have got these things. So these things, when we put the values of q is equal to t, we will get in this function. If you will put q is equal to t, qt is equal to 0, then we will get this terms will be
40.
This it will be 0. So that will be 120 by 3. A will be 40. Similarly, B will be divided by 3, that is 1.667. Here discount rate was given 10%, that we can write 0.1, and the time duration that was given is 10 years, and we have to find the value at t is equal to 5 years. T is equal to 5. So substituting these values, so we know that
Sir,
formula already. Yeah,
sir, you have replaced these A and B with means you have replaced PT and QT with A and B, right?
correct.
Okay. That's why I'm taking like A and B has suddenly come so. Okay.
No. This is if you go to that just give me. If you will go through the derivation of this formula, you will get these things where these things are coming.
Okay. The A greater than 0 under that cover.
Correct. When we will solve these things, now you will get the how these A and B values are coming.
Okay.
Okay. I'm not going to derive this whole equation. I'm just using that derivation.
Okay.
Sir, B below is 5 by 3. How? Sir, B is 5 by 3. Yes. Take.
So these things we know QT is equal to A by B 1 minus 1 plus d to the power t minus t. So we have here capital T was 10 years, and we have to calculate this at the function at the t is equal to 5 years. So if you will put these values in this formula, qt will be A, we have just calculated 40, B was 5 by 3, so we can write 3 here, 5 here, sorry, 5 by 3. So this thing will go up. This will be 3, 5, and 1 minus 1. 1 plus 0.1 will be 1.1. T is 5 minus 10. So if you will solve this equation, this will comes out to be 40 into 3 divided by 5. This will be 24. And 1.1 to the power minus 5. It will comes out to be 0.62. And if you will multiply this thing, this will comes out to be 9.097, or you can say 9.10. So here we have calculated the value of QT at the year 5 will be 9.10. Anyone having any doubt? So in that case, we have got QT is equal to 9.10. Let's see what's the next aligned. Next thing is the tutorial questions. This is the only tutorial session for this class because this is already an explanation of this derivation. So it says consider a competitive mining industry consisting of n identical mines. So these hoteling rules and all the competitive and the monopoly market we have self explained in the terms of mining activities. So in that we have I have added an example. Consider a competitive mining consider a competitive mining industry consisting of n identical mines. Assume that a rational expectation of each mine owner attempts to maximize its profit by, and this function is written as this thing. And it is subject to R is equal to minus QT, and R0 is at R0, and R at the maximum time period. That means resource at the maximum time will be exhausted to 0. Assume that C QT will be equal to this one, and the price PT will be determined by the aggregate value, this thing, with a linear demand function PQ. Demand function is given as PQ is equal to alpha minus BQ. Obtain the solution in general and apply it to the parameter. Alpha is equal to, alpha is given here $1,000 per day. Beta is given $0.5 per day per ton square. Alpha is 100 rupees per ton. Beta is equal to 0.02 days ton per square, and the lambda is 0.1 years, and is equal to 20. R is equal to 200,000 tons. There are 250 mining days per year. So all the information is given. Let's try to solve this. So when these things, all the three things are given, we know the value of formula for the Q. This is initially we have to note down, this is talking as a terms of competitive mining industries. So it is initially explaining as it's a competitive market. So for the competitive market, Q is equal to A by under root A by B. So these things are directly coming from the derivation we have derived for the explanation derivation for the Q, that is comes out to be under root A by B. We know PT is equal to alpha minus beta and Q star. QT was equal to alpha 2B and beta minus alpha 2B. So don't worry about this kind of long questions. This will not come to your exam, but this will enhance your understanding for the subject. That will be multiplied by e to the power lambda t minus t will be equal to C1 minus C2 e to the power lambda t minus t. And here the t and t can be, t is determined by C1t minus C2 1 minus e to the power minus lambda t by delta is equal to r. So if we will see the alpha, A is given as a 1000, B is given as 0.5. So if we will put this value into this, Q comes out to be 1000 divided by 0.5 under root. It will come out to be as a 44.72 tons per day. PT we have just written the equation. PT, we know alpha is given as 1000, sorry 100 minus beta is given as 0.02, and what else, n is given as 20. So if you will write it down as a value of 20, and Q we have just calculated 44.72. If we multiply all these things, it will comes out to be 100 minus 0.02 into 20 into 44.72, 82.12 tons, $82.12 per ton. This is the mining rate, PT. This is Q star. Same thing. If you will take calculate the T, if you will put these things into the in this formula, we will calculate T. T will becomes out to be If you will calculate this thing in the formula C1 C2 considering these things, so this will comes out to be 14.07 years. Now most important thing, QT. So now QT will be as we have the demand function was given as in this way. So QT will be 71.43 plus 8.73 e to the power lambda t tons per day, and production rate will be evaluated as 74.43 3.49 lambda t dollars per ton. So these things we have evaluated whatever the question is being asked. So this is the general solution. Whatever the demand rate will vary and this time to duration horizon will vary. We can just put the values in this function, and this is the general solution. In this we can say where we can see PT as a component which grows at rate of interest. So that's all for this long tutorial question.
Sir, sir, can
Yes.
you repeat the can you repeat the question once again? That how actually I missed the first part, so that's why like.
Okay.
Can you just
So it says consider a competitive mining industry which is consisting of n mines. So assume the
Hmm.
rational expectation of each miner wants to optimize its mining experience. So it says to maximize this function, which is subjected to R is equal to minus QT. R not will be a initially resources will be R0, final resources will be 0, that RT is equal to 0. Assume that CQ is equal to this function and that price PT is determined by the function of PT. So we have to generalize this value of PT and QT with a linear demand function PQ is equal to alpha minus BQT, and all the other parameters are already given. That's alpha is given as 1000 per day, beta is given as 0.5 tons per days per ton square, alpha, beta, this all other things are given. So we have to we know that if you go to the derivation explained in the slides itself, you will see this all these values been all the formulas are already been derived that q is equal to under root a by b, pt is equal to this function, qt is equal to this, and t will be defined by this function. When we put all these values in this formula that has been given, you can calculate the q, that is around 44 tons per day. You can calculate the pt by that comes out to be 82.12 per ton. Can calculate the time period, that is the maximum time that will be exhaustion time, that is 14.07 years, and we can derive the generalized expression for qt and the pt. So this is the function that we have derived when putting all the values in this or whatever we have been using. So
okay, sir.
okay, so that's all for
Okay,
this
sir.
week. If you,
Sir, can you
Sir,
go back to
another
the
question.
previous question?
yeah, one by one please. Yeah,
Can you
please.
go back to the previous question? Actually, I calculate the magnitude of the price elasticity demand. Is it correct or wrong? I didn't get it actually.
Which one? This one?
Yes, the price elasticity demand as a given time t0.
Hmm.
So it I have calculated and it came 0 minus 0.63.
Which one
It
you
is
are talking about?
this one. No?
Is this
For the
is the same
same
question?
demand function above, calculate the magnitude of price elasticity demand at time t0, a discount rate given and resource lasting given also.
So that right answer was 9.10. I think you have made some mistake.
No, no, you didn't calculate the price elasticity demand, na? You have
Okay.
calculated QT only.
QT.
Yes, but there again it said price elasticity demand. The next part.
Okay. Got it. Got it. Okay. Sorry, I just missed that part. No. Hmm.
Yes.
Calculate
Price
the.
elasticity
So
demand. Um,
So
correct.
what
Correct.
will
del
Correct.
D divided.
Just let me
del
solve.
Q by
So
del PT into PT by QT. This is the
yeah.
function.
So sorry, I just missed that. But thanks for mentioning it. So the demand function was in that question was QT is equal to so we can write demand function in the function of 120 is equal to 120 minus 3pt by 5. QT will be 24 minus 0.6 pt. If you will normalize this equation, this will comes out to be this. From the previous question, we have got that P naught will be
No,
P
sir.
naught we
Here
have
T changed. Value of the
uh,
T, small t, it is changed. It given 0. So we
oh,
have to calculate Q2 again and PT
yeah,
again.
I know. Just let me just solve this question from the beginning. So first we need to calculate the price elasticity demand. So we calculate the initial price. We have to calculate first the initial price. So initial price will be having a function of a discount rate that was given 10% and T was is equal to 10 years. So PT was 40 as we have calculated in the
Sir, is it required to calculate initial price? You can calculate QT from the calculation A by B 1 minus 1.
C. If you want to solve this demand function that was initially, let me just rewrite it. 3pt plus 5qt is equal to, so just
120.
remove all this. I will just solve it from the beginning. Okay. So initially, what we have to do? Initially, for solving that question, uh, 3pt plus 5qt was equal to 120. We have to first determine the choke price. Choke price will be PT. PT will be we have to calculate the PT when QT is equal to 0. So when PT equal to 0, 3PT will be equal to 120. So PT like choke prices comes out to be 40. That's 120 by 3. That's comes out to 40. Now we have to calculate the initial price. So initial price we have to calculate for the initial price. Discount rate was given 10%. That's 0.1 and time was mentioned as 10 years. So PT was equal. So PT was PT we have just calculated 40 years and therefore P naught was equal to PT as from the demand function and the formula D to the power T. If we calculate this thing, that's 1.1 divided by 240. This things P naught comes out to be 15.42. Okay. Now we have the initial price, we have the value of PT. Now we can calculate the magnitude of price elasticity. So price elasticity says demand function QT can be written as 120 minus 3 PT to the power 2 divided by 5. That will be equal to 24 minus 0.6 PT. Now from the previous calculation, we know PT was 15.42. We know, so then Q0 will be 24 minus 0.4, the value of 15.42. So in that, if you solve this, that Q0 comes out to be 14.748. Correct. If you solve this equation, this will be the now that if you will see, now we have all the values. So we have to calculate the magnitude of price elasticity demand, that's equal to dQt upon Qt divided by dpt upon pt. We can also write it as dqt upon dpt into pt upon qt. So we know dqt by pt we have calculated as 0.6, and this pt we have calculated as 15.42. So 15.42 divided by 14.748. So these things comes out to be around, if we calculate this, I think it comes out to be 0.627 or 0.63. So the answer for the magnitude curve will be 0.63. This is the same thing
There will
you thought?
be negative sign before 0.6, or
No,
there
no,
will not be.
this thing will always be in the modulus now, so negative sign will always fade away. I know that demand curve is like this on the negative curve, but we have to represent it in a positive term. Here's the modulus you can see. Whenever the anything comes in the modulus, it will always positive. Any other doubt anyone had it? Otherwise, we are done for this week. Thank you all of you.
Sir.
Yes.
Sir, I have a question which is not related to this one. So can you just means it is there in the assignment itself. So what is embodied energy? Like it's the question is given like
embodied energy. Embodied energy means how much energy is required to mine that material. Suppose iron ores, there's a material that is available in the mines. What is the embodied energy that we will be required to mine that iron from the ores till the
it's
end
like
consumer
potential
use?
energy. Some type potential energy is like related
Potential
to
energy is different.
Sir, that embodied energy, sir, just explaining.
Yeah, embodied energy, it is the energy associated with the manufacturing of the product or service. Suppose, as I told you, iron ores cannot be used as a iron itself till the getting it as a usable form or the service form. That whatever the energy that is consumed for that mining or the reshaping. Suppose you're using a mobile phone, whatever the amount of energy that is going to be used from the its mining to the manufacturing and all the parts that has been everything is having its own embodied energy. So this thing is it includes the amount of used energy used for the extraction, manufacturing, transportation, distribution, everything. You have to consider everything. So these things are more usable when we do the life cycle analysis. That will be the end part of this course, when these things will be more easy to you understand.
Okay.
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 Okay. I think we can just. Thank you. Thank you all of you.